The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Thanks for joining us. We're going to get started here in about 2-3 minutes. Got a great topic for you all today, understanding single and multi-channel Wi-Fi design models. Doesn't get much more exciting. Am I right, Chris and Jim? Thoughts?
That's right.
Thrilling
stuff. Thanks all for logging in early, you early birds. If you don't mind letting us know, thanks Mike, already jumping the gun. If you don't mind letting us know where you're logging in from, we'd appreciate it. I'm here in the office in Cleveland. Jim is in Cincinnati, and Chris is in a very interesting predicament. He was in Corpus Christi, as you all know, and they had a hurricane last week. So what are your whereabouts right now, Chris?
Hey, good morning. I'm still in Corpus Christi.
Oh, you are? Okay.
Part of my, some of my furniture is in other places. Some of the fence is missing a little bit. But yeah, I'm here.
Good. I didn't know if you were escaping to Dallas or Houston. We had had a little email back and forth this weekend.
Yeah, after 3 days without power, I was about to just pull it and take the family elsewhere, but I think 3 days was my limit. So.
Right. All right. Well, we've got Mike in Vancouver, Dan in Stockholm, Sweden. Welcome back, gentlemen. And
yeah, our friends in British Columbia are always the first to check in with us.
They are indeed.
Something's in the water up there.
So that must mean Olivier is not logged in today, since he's slow with the reply. I'm looking.
That's who I had in mind, but Mike, he filled in from Vancouver.
We'll take you, Mike. And we've got lots of shy folks in the audience, but I see a lot of familiar names. Robert, welcome back, and Trey, Mel, Kenneth, John, Jeffrey, and some new names in here too. Frank, I think, is a new one. Eric, welcome back. Certainly not a new one to this thread. For those of you just logging in here, if you don't mind letting us know where you're dialing in from, that would be great. We're going to get started in about a few seconds here. It looks like we're at 11 o'clock Eastern on the nose. So as I said just a few minutes back, we've got a great webinar for you all today. For those of you just logged in, we're going to talk through single and multi-channel Wi-Fi design models with Chris Minton, who is in Corpus Christi. Went through a little hurricane experience last week, as we kind of talking through a little bit here before the webinar started. So we've got a backup plan in place just in case Chris's Wi-Fi goes down. Jim Vada is waiting in the wings, ready for any sort of interruption to jump in and continue Chris's slides. So welcome, Jim, welcome, Chris, welcome everybody for joining us today.
Clear to send, I think that's what we'll call it.
Yeah, there you go.
A little Wi-Fi nerd humor there.
I'm in the queue, just waiting to be transmitted.
So, a couple of quick updates today. Same as always here, our presentations are generally designed for continuing education towards CWNP credits. We don't get into any of the product information or tours or anything on these webinars. You can go to go.sevensignal.com/tour to register for one of those. We have those every Friday. If you don't want to engage with one of our awesome sales reps or a sales engineer, you can certainly go to that tour and just see the products for yourself. All of our archived webinars, and there are some product tours on YouTube, so you can go there. We typically post these webinars about an hour after the live presentation, and you can also get some slides now through our Twitter account. So for those of you Twitter users out there that want to get access to our slides, you have to follow us. And we are, Kelsey, you can confirm that we're giving away some swag today for some followers on Twitter too. Is that right?
That is correct.
Awesome. So we'll be picking out 5 lucky winners for some 7 Signal swag. So if you're not already following us on Twitter, please go ahead and do that. And if you're not a Twitter user, that's okay. We've got some trivia questions here for you all today, and we'll be giving out some swag on there as well. A new bullet here, we are participating and sponsoring at Wi-Fi Now. So we're going to drop the link into the chat later on. So maybe we'll see you all at Wi-Fi Now. They've changed from a in-person event in San Francisco to a virtual event that's coming up in September, October timeframe, last week of September, first week of October. So we're looking forward to seeing you all there. We're going to talk about supporting remote users, among other things. So very exciting stuff. We've got a great promotion. For those of you who are not aware, you can go to go.7signal.com/50 for 50 to get access to our free trial of Mobileye. So that'll help you with any of your remote work or your strategic IoT, making sure those devices stay connected. So a little bit about us. 7 Signal was started in 2007, hit a lot of major milestones along the way. Really proud of our 5 million devices, and we're on over 200 networks around the world, certified in over 40 countries, certainly GDPR compliant, 14 patents. So what you see from 7 Signal, you are only going to see from us. We're here because connectivity matters to the digital experience of your end users. And 7 Signal gives you visibility unlike any other solution on the market. With our Mobileye and Sapphire Eye modules, all part of the 7 Signal platform, completely device and AP agnostic, and giving you an outside-in approach, which is unique to this space. So what we're doing is we're looking for the top 7 Wi-Fi problems. Everything in the world of Wi-Fi bubbles up to one of these 7 problems, and they present themselves differently to your end users. And if you're not a Wi-Fi engineer and you're joining us today, you'll know that, hey, the Wi-Fi is either fast or slow, or you can't connect, or it's intermittent. There's a reason behind it. And you don't necessarily need to be a Wi-Fi engineer in order to use our products. How our products work is we're running active and passive tests on your network and on the devices for things like throughput, packet loss, latency and jitter, MOS scores for your VoIP users out there. We have a full spectrum analyzer with packet capture. So sometimes people like to look at our solution this way. So this is your standard LAN infrastructure. So what our customers before they came to us were experiencing is that inside out approach, and a lot of you on the line who aren't customers have this today, and there's great solutions out there for infrastructure monitoring. You've got your SolarWinds, you've got your access point providers as well, your Aruba, Mist, Extreme, Cisco. You've got your application server companies out there like your Netas and so forth. So we don't play in that space. Where we play is on the outside. So Mobileye, for instance, lives on the devices, any Windows, Mac, or Android device, scanners, PCs, any device that's strategically necessary for your organization to function. If sales depend on it, widgets, or lives in a hospital scenario, or students. So Mobileye is that agent that lives on that device. Whereas Sapphire Eye is our perfect client or sensor that lives up in the rafters with the access points, giving you full visibility into your service level quality and the RF. So just a different way to look at it. So Jim and Chris, why don't we get into a little trivia and see how much information our audience knows about today's topic. And I'll start with our first poll. And again, this is for swag. And so the way this works is I have to go in after the webinar and see who answered this question first, because GoToWebinar doesn't have very sophisticated polling and trivia questions. So our first trivia question for some swag is, which channel plan came first, single channel or multi-channel? So take a moment and answer that. Our organizers can see those answers coming through. And once it slows down, I'll share it. Let's close the poll out. And let's see how they did. Jim and Chris, how did our audience do here? It says 61% say single and 39% said multi.
Yeah, you would think single channel would be first, but actually it's not. So it's actually multi-channel was the first, and single channel followed, which is pretty amazing.
Yes, indeed. So our audience was incorrect on this one. Some of you were correct. Let's see how you guys do on the next one. Let's
That's
hide these
good. That
results.
just means I need to stick around and learn something here from
Yes,
Chris.
you guys are going to learn something today.
Yes.
All right, this next one is true or false, and I'll read it as I post it here. True or false? You don't need to do a site survey if you're going to use single channel architecture. Lots of responses coming in here. All right, seems to have slowed down. Let's close this poll and share these results. Chris and Jim, we've got 14% say true and 86% say false. How did they do on this one?
It is false. So well done, y'all. People are believers in the site surveys, and that's a great thing. But yeah,
Yes.
that is a common misconception. And in fact, if you want a Wikipedia, we were just talking earlier, that's actually on Wikipedia. That's one of the benefits that they state for single channel architecture, which is pretty interesting.
Yeah, if you're ever wondering if you need a site survey, you need a site survey. You can't have too many.
Indeed. So I'm going to hide those results, and hopefully you all can see Chris's slides now. Chris, if you don't mind starting out by telling us a little bit about yourself, and I'll do the advancing for you today.
Fantastic. Can you guys hear me okay?
I can.
Great. So everybody, thank you so much for your time. This is going to be a good one. This is something that we really don't talk about a lot, but actually has a lot of significance. And before I get into that, though, just like an engineer, I want to get right into the details and skip who I am. I am Chris Minton. I am a sales engineer with 7 Signal, coming up on my year anniversary, which is really exciting. I've been in the wireless and cloud and security space for quite a while, and I am super jazzed to be talking with you guys with one of my favorite topics.
Yeah, right on. We're happy to have you.
Thank you. So let's get into it real quick. So we're going to start off with the obvious definitions. When we talk about multiple channel architecture and single channel architecture, we're really talking about, if we talk currently, it's about RF planing. If we talk about a little bit older understanding of it, when I mean older in Wi-Fi, that's like what, yesterday or this morning?
Right.
They seem to change so fast. They actually refer to it as channel assignments. And the main takeaway that I would like for you guys to walk away with this presentation on the difference of MCA versus SCA is how it relates to you and your work as a Wi-Fi engineer. MCA does a lot of the heavy lifting for you. You can call it flexible. You can also call it non-flexible. And your Wi-Fi, your career, your day-to-day will be somewhat different than if you are in an environment that is single channel architecture. With single channel architecture, you have more flexibility. Is a double entendre when we talk about this, because flexibility, it means rigid. In my brain is single channel architecture. You have the ability to make a lot of decisions about what applications and what traffic will be allowed on certain channels. And we'll get in that here in a little bit, talking about some of the different two methods that is in single channel architecture, and they even try to use it in MCA as well. But I wanted to relate with you that in your work, if you have a single channel architecture design or thinking about it, from the workload, you will be a little bit more involved. Every voice conversation, every new application, all of these things will be looked at with scrutiny, because you actually control the channel plan of even up to the application of what that traffic can traverse. And if you're in larger organizations, which most of my career has been in enterprise class, that means lots and lots of different teams all around the globe. If you're in a small organization, that just means more work for you to do as you put on different hats. But you will be looking at security, and you will be looking at routing, and you'll be looking at a lot of other things on top of just the regular performance of Wi-Fi. So that is the big takeaway for the two that I want you guys to come back with this of this quick presentation over the two. But I will go ahead and state the definition here. So MCA is the most common, and from our poll, it was the first. It is probably, I don't have a real, I look for percentages, but it is the lion's share of wireless RF planning mods that are in today. You basically controller type architecture, and the channels are designed and they're implemented for the BSS, so they basically they have minimal interference with one another. Single channel architecture, if you look at some of the older documentation, it's really a little bit not a lot there, but some of the newer information is coming out that has quite a bit more on single channel architecture. And some of its complexity, which is really interesting, since it's hardly used, but it is used in some verticals that I think a lot of our customers in our sweet spot is as well. And you basically place all the APs on the same channel, and the controller basically does the work. Don, if you wouldn't mind, next slide, please. So when we talk about MCA architecture, real quickly, it's the #1 design today. We most know that we go through our wireless, how it works. We basically let the controller handle the channel plan. The devices basically are use a lot when it comes to roaming. The clients will actually make those decisions. But when the first design for MCA, again, well, I say you, but most of the time it's the computer that will select the channels that you're going to use on the 2.4 and the 5, and it's obvious the channels that are available. And then you configure these APs, use these channels, and then you basically stagger those APs around your area to have good coverage, and try to cut down on channel interference. Next slide, please. So the biggest thing with the multi-channel architecture is, again, the channel plans. And as we know, in the 5 gig band, it's pretty easy to use because of the obvious number of channels. And then on the 2.4, there's really only 3 channels there that can be used that are non-overlapped. But what's really interesting, and this one comment here at the bottom about not uncommon to disable some 2.4 gig radios, that is really interesting, because all of the information that I'm presenting today is from the CWNP text. Again, as you guys know, it's transparent. It focuses on wireless. It doesn't focus on a certain vendor. But this is really interesting because, as you guys know, in a multi-channel architecture design, having those powers toggled is really how MCA does its channel planning, right, with the clients. And it's really interesting that all those decisions are constantly being done in order to find that great smooth connection, especially when it comes to roaming devices. And I believe you'll see how single channel architecture is implemented in some other, mostly in the verticals of healthcare and education, because healthcare and education have a lot of devices that count on wireless, but they also are stationary. And they are also very, when you talk about non-typical Wi-Fi devices as biomed type equipment, those devices are very expensive and are supposed to have a very long shelf life. So they are stationary, but they're also wireless, and they usually have some of the older standards. So it becomes really clear why some of these verticals really latch on to the single channel architecture design. Next slide, please, Don.
Yep. Sorry, buddy. Wrong way.
It's okay. So again, with multi-channel, there are some challenges. Yeah, again, is it a bug or is it a feature? That's that kind of nomenclature that we all kind of laugh about. A challenge is really specific on to what design and what problem you're looking to fix. And this first statement here about the output settings must vary to each AP. And again, that's because of radio resource management and all the other type of vendors and their algorithms actually using that and constantly making those changes to make sure that everybody can hear what they need to hear. And adjacent channel non-overlapping interference, excuse me, that's a mouthful, is always present, and the controller and the APs are always working to try to reduce that. And then again, you are back to a site survey question that we had. A lot of people in Wi-Fi and non-Wi-Fi, and IT and non-IT, they believe that once the Wi-Fi has been installed, the Wi-Fi has not changed. And it's really interesting over time, if you have a wireless environment, how just moving different boxes, different cabinets, relocating rooms to other rooms, all of these things, new technologies that are coming in, can actually really change the RF propagation. And that's why we always say that sometimes not sometimes, but it's always good to say if you have to ask yourself when the last time I had a site survey, it's time to do a site survey and see if things have shifted over time. Next slide, please. So with that being said, let's look at single channel architecture. And if you look through the literature, some of the older literature really barely just covers the surface with single channel architecture design. Really just kind of just says, hey, you use one channel for one band, another channel for another band, and away you go. See you later. It doesn't. You have zero roaming. It's completely no delay or what have you, which is a little silly. Some of the newer documentation, again, and some of the literature out there goes in a little bit more detail about some of the benefits of single channel architecture. And I believe it is because of healthcare and education. It's a great use case for the healthcare and for K through 12 and higher ed. Especially having types of networks that need to be campus wide, that don't allow for a lot of specific connections into private or independent type resources like just internet or guest access to the home page or what have you. So single channel architecture, is the actual definition, is a group of access points, and they make up a BSSI, right? And they span the entire campus. And the clients, as they're connected, they believe that they're just connected to a single AP no matter where they roam. So all of the transitions as a person roams from one to the other is really transparent. And the client, as we'll see, actually doesn't make that decision in SCA mode. It's actually all done by the controller. So that is one of the biggest differentiators between making a decision between an SCA or MCA plan. Next slide, please, Don. So I want to get to just a little bit of the high level of single channel architecture, and you'll notice right there that's the handoff of roaming. It's 2 to 3 milliseconds. If you guys MCS or some MCA, they're a little bit more than that, but there is some documentation literature out there that there is a zero delay, and as everybody knows, even as you roam, there will always be a little bit of latency. It's just a fact of physics. And the main difference with the virtual cell is that, again, the architecture actually makes the decision about roaming and not the client. There are some usage of SCA and virtual cell and virtual WLAN all use it the same. They all have different meanings. They do not all mean the same thing. So sometimes in the vendor literature, it gets a little confusing what people are referencing to. And each vendor, say like Fortinet Maru or Fortinet and some others, just for example, or Cisco, when they use their own proprietary algorithms for making those decisions in single channel mode about which AP is the best AP for a client as they're walking the park, as we say. So two key takeaways for that, again, and I just want to keep hammering that in there, is that the client is responsible for roaming decisions on a multi-channel architecture plan, which is the lion's share of the designs today. And single channel architecture is actually handled by the WLAN controller. And I put controller there because I really meant the entity, not the actual client. Next slide, please. So again, I wanted to hit some of the misconceptions about single channel architecture. And this was one of our trivia questions. And there's a lot of literature that says that you don't need a channel plan if you're going to do implement a single channel architecture in an environment. And for reasons that we just discussed, that is something that you definitely have to look into. And there's misconceptions out there that you don't need to perform a site survey or having a living site survey. And again, that makes sense about how people would just say, oh, you just set up a single channel plan. One radio's got one channel, the other radio's got another, and then away you go. It's actually a little bit more complex than that. And again, the physical medium is constantly changing, and what you put in today sometimes might not be what it looks like 3 months or 4 months down the road. So it's always good to, again, run those site surveys, especially having some of the newer technology that has the predictive analysis and the real-time analysis of how things are going in the environment is very, very helpful to make sure that plan is working. On the next slide, Don, if you would, I want to talk about some of the coolest things about single channel architecture, and you'll probably see some of this in multi-channel architecture. And this goes back to the point about how much work and how much you want to be involved as a wireless engineer on the wireless side of making decisions on clients being able to connect to certain resources. So there's two different design mods for single channel architecture. And one is referred to as channel striping and one is channel layering. Now, they get used independently, but they are two separate things. And also vendors have their names for them as well. But basically with channel striping, that is for multi levels, like a hospital or a doctor's office that's several floors, that you can implement channel striping to have basically the channels on the same floors and be able to segment that way. And again, this segment different physical and virtual layers of WLAN. I think that's one of those statements that a lot of people, especially in academia and in vendors, they'll state, and then they just basically just say, hey, that's just something there. That statement actually means quite a bit, in my opinion, as a engineer and as being responsible for things in past jobs, is that if I have the ability now, if I'm in SCA mode, I can actually basically VLAN off channels, and I can VLAN channels off to applications, and I can VLAN those applications off to certain resources. And so that makes that a very powerful tool, and especially where that type of segmentation or that type of resource is needed, especially again back to healthcare, in research labs, you see this as well, and especially in higher education. That is a very powerful tool and very nice at your disposal to be able to fit that business need. So sometimes things don't have to be done all the way up at the firewall layer. Again, I'm an ex-security guy, so I believe security today, security tomorrow. Not saying it's not a replacement for that, but I'm saying that it is a tool that you can segment actually traffic and traffic patterns for. Also, it is something that you will be responsible for. And you will be and from my own experience, you will be in a lot of meetings about not even just connectivity issues, but planning, because now instead of your MCA design, where you didn't have that type of channel plan and that type of RF being used, you now are causing some segmentation, and you will always those pieces will always be looked at, especially in larger enterprise environments, by other people saying, hey, that might be causing issues or that might be causing delay. So again, it's one of those good tools or possibly not a good tool, but be aware of it. And then channel layering is pretty much common. MCA does it as well. It's just really just multiple co-location APs, same area on different channels. Again, high density networks. I love this again because when we talk about channel layering and we talk about MCA and they talk about high density or very high density, we have to have an acronym for that, VHD and HD. That in MCA mode, they really just to fit that is they lower the power on everything. Throw more APs to very high density environment, but lower the power, right? And so with channel layering, it's a little bit of the same concept, but with the increase that the channel capacity can be dramatically increased. Don, let's move to the next slide here. Trying to stay on topic here. Oh, good. I was about to go down. I felt myself going down a wormhole, so I'm glad I got it right here at the review. So again, this content, this information is from the literature of the CWNP. This is not taken from Wikipedia, even though we referenced it as something not to do. This is not, we didn't use a lot of vendor information, but we wanted to give a very understanding of the fundamentals of the wireless, of the standard, of what the foundation is. And then you can talk to your vendor or to your reseller to talk about, if this is something that you're interested in, you can talk to them about the vendor's products and how they actually implement this. And again, most people don't wake up and decide I'm going to move my entire hospital, my 5,000 employees to a single channel architecture on Tuesday. Most people will have this environment. Once they get hired, it'll be inherited. And usually when this comes into play is when there is a acquisition or a new business or an opportunity for a expanse to have the ability to say, hey, well, maybe we should try this for this environment. So I want to keep that in the back of your head as well. And so again, the review is what we know with multiple channel architecture. Go ahead and go to the next page, Don, if you wouldn't mind, please, sir. The single channel architecture is what I really wanted to hit. Is that, again, you'll notice that bullet point, I mentioned virtual cell handles client roaming decisions. I purposely put interchangeable definitions because we see this in vendor literature. They'll also call it the controller. They'll also, we'll call it just the WLAN. The main thing to note there is that it's not the client. The controller actually tells the AP which clients should go, and how that is done is completely different per vendor because a lot of them use their own proprietary algorithms on making that decision. And then with single channel, you have the ability to do a lot more segmentation, and you can do efficient use of the channel capacity. But again, it will be a little bit more work, and it will be a little bit more troubleshooting and verification. So make sure that you've got really good site survey tools and monitoring, and keep your ear to the ground or nose to the grind, or however that saying goes, where you're aware of what projects your business is having coming on to make sure that you're going to be able to modify and fit that needs of that environment.
Mm-hmm.
So that is my quick review of the two. I believe now we can do the best to answer some questions if there are any.
Yeah, awesome. Thanks a lot, Chris. I appreciate that. Great presentation. I had a couple of questions come through as you were talking here, so I'll get to those first. For those of you who aren't familiar with using the GoToWebinar control panel, you'll just use the drop-down arrow in the question pane, and you can send your questions our way. So this first one is from Rodrigo, and it's got a couple layers to it, but I'm going to ask the first question first and see where that takes us. It says, hi, in single channel architecture, how is interference handled by other APs?
Sorry, I was on mute.
Oh, you're on mute? Okay.
Yeah. So you're always going to have interference. That's just the name of the game. The general construct is that using an SCA design will actually have less interference because you'll be using certain channels for the certain RF for that BSSID.
And that
Yeah.
actually, sorry, go ahead, Jim.
Yeah, I just wanted to add too, in an ideal SCA deployment, the transmissions from all the 8 access points are coordinated. So the controller schedules when each AP transmits. So even though they're on the same channel, they're not transmitting on top of each other necessarily. So interference in the sense of causing collisions should be somewhat limited if it works right, which is a big if.
All right. Thank you for that, gentlemen. Next question here is from Ahmed. Is the single channel architecture available from every wireless vendor?
That is a great question. So you have to be, obviously a controller environment. So it has to be at least enterprise class. Jim, do you know any that don't do SCA architecture?
Well, I'm only aware of one vendor that does, and that's Fortinet, who acquired Maru last year, maybe 2 years ago. And Maru was kind of the king of SCA, and Fortinet has continued that product line. But I'm not aware of other vendors that do SCA as well.
All right, thanks, gentlemen. That was the last question I'm pulling through that's not related to getting a copy of today's slides. So you can get a copy of today's slides simply by emailing me or getting them from our Twitter account. If you're going to follow us, it's @7signal.com. And of course, you can get a recording of today's presentation on YouTube. So with that said, we're going to get you guys out of here on time today. So thank you all for joining us, and we'll see you all next week. Thanks, Jim and Chris.
Thanks, Chris. Thanks, Don.
Thank you, everyone. Have a great day.